Go on, Mr. Jala.
Okay, good evening, good morning, good afternoon. We can start our class for tonight.
Good afternoon.
Okay, thank you so much. So you already know this command. I already shared the data for tonight, weather data. Okay, for Excel file. I already open it. You can open and see the data. Okay, we have two data. One is temperature and another is rainfall. Okay. So we have two data sets here. We need to sort. First, we calculate the mean, median, and mode. Okay. So for median, we need to sort our data whether in ascending or descending order. We can use only sort function if you just open the Excel file with Excel's read. Okay. But we use the read table like a table. In that case, you need to use the sort rows. Then our data by default is ascending order. We can run it. So we have sorted our data. Now we can calculate the mean value using the mean function. We will calculate the mean for temperature data. Okay. So sort data dot, we use a dot to access the variable temperature. Here we have a temperature. Then we want to take the whole rows, but the temperature is in first column. Okay, that's why we use the 1. We can calculate the mean, but if you have the missing value, okay, sometimes you have a missing value on your data, then you can use a nan mean. Nan means the MATLAB will skip the nan value if you have it. Then we can use the built-in function median. We can use the built-in function mode. Let's run and see. So we got the mean value, temperature, median value, and mode. So let's learn something about the statistics. Okay. Because understanding is the key, and we need to know the application of our statistics. And interpretation is very important. Okay. So we know the average condition like mean, median, mode all show the average condition. Okay. So we already know the mean, how to calculate this. This is a very basic statistics. If you have the xt like time series data, we have a time series data like 10% rainfall. So t is a 1, 2, 3, like you have a time series. If you have the daily data is t is a 1, 2, 3, 4 is daily day. If you have year or month, okay, this is a time series data. Then we sum from t1 to n. Then we divide it by number of elements. This is the mean value. But be careful about the mean calculation, not only in MATLAB. You also need to be careful in Excel or R or other programming languages, okay, or other softwares in SPSS, for example. Anywhere, if you want to calculate the mean value, be careful about the missing value. If you have missing value, you need to define the missing value. Otherwise, your mean result will be influenced by the mean value. So your result will be incorrect. Okay, be careful. And in meteorology, mean reflects the climatic status. Like if you have 24.5 degrees centigrade, then you can describe this is a mean value about the describe the climatic status. Okay. Even you can sort your data in Excel. Like in a data, you can ascending or descending order like this. Okay. But we sorted in MATLAB. For median is the center of the population. When you have xt value, you should arrange like ascending or descending order. But for median, it depends on the time series data. If it is odd, okay, the element number is odd, then you have to calculate like this equation. You need to use this equation. Say for example, if you have the temperature data, like for October, right? October, yeah, 31 days. So these are odd value. Then you need to use x is the time series. Then n is like 31 plus 1, 32 divided by 2. That means 16. So you have a 31-day temperature in Fahrenheit. So what is the median value? Number 16. Okay. Then 67 degree Fahrenheit. But if it is for the even, n is the even number, like for temperature in June is 30 days, right? So how to calculate the median if you have even number? Okay, the element of the value is even. Then the equation is x n by 2. That means the 30 by 2, 15. That means 15 is 85 degree Fahrenheit. Then 15 plus 1, 16. So you need to sum two values, median values divided by 2. That means 85.5 degree Fahrenheit. Median, the advantage of this median, median is not influenced by the extreme value occurring in the sample. Like if you have the extreme value like 93 degree Fahrenheit, we have extreme value, we can have more than 93. So we can take the median value without getting influenced by extreme value. Okay. Then what is the mood? Mood is most frequently occurring value in the sample. So for example, here is a mood is 3 because 3 frequently occur in this sample, right? So in meteorology, mood is mostly used to summarize the wind direction, like from which direction wind is coming. Okay. But if you want to see mood for the disasters, like you have many disasters in your area, like cyclone, drought, then extreme temperature, weather, etc. But you can use the mood, which disaster is frequently occurring. Okay, so mood helps to know the most occurring value in the sample. All right. So this is the average condition. Now we can analyze the variation. You know the variance, right? So we can calculate the departure or anomaly, variance, standard deviation, and minimum, maximum range. This is all are like dispersion in statistics. This is called the dispersion. Okay, like how the value like difference from the mean value. Okay, what is the dispersion? What is the dispersion of the data from the mean value? We can use the dispersion like variance, anomaly, standard deviation. Okay, range, minimum, maximum. So let's learn about the anomaly, variance, and standard deviation. Okay, then we can calculate in MATLAB. So departure or anomaly is just about like you have a time series data, xt, like temperature, rainfall, or whatever any data, then you just subtract the mean value. T is 1 to n. When you subtract the mean value, your data will be centralized. Say for example, like this figure. Can you see my screen? Hello?
Yes, can be seen, Jala.
Okay. So say for example, these are temperature data. If you use the raw data, you can't see the variation clearly, right? Even it's not understandable. But if you centralize, like if you just subtract the mean value, your data would be centralized. Mean value is the central 0, right? Then you will get the positive and negative value from like 1980 to 2016. You can clearly see the variation of the temperature, isn't it? So why use the departure or anomaly? Why use centralize the data? The reason is we want to remove the seasonal or annual variation effects. If you want to remove the seasonal effects or annual variation, then we can use anomaly or departure, like we centralize our time series data. So this is the advantage of using departure or anomaly. Okay, so we just subtract the mean value, isn't it? So we have a temperature data, then we subtract by mean value. then you can get the departure. So you got the departure. Okay, like we got the positive and negative value. Now we can clearly see. So for example, we just can, tomorrow we will show the visualization, but here departure, yeah, just for, yeah. So you can see the variation. Here is 0. Okay, we centralize the data. If 0 is in, okay, we can see the variation. We can see the change of temperature. Did you get it? So now we can see easily the variation. Okay. So we can use a departure or anomaly. Then variance. What is the variance? Variance is like we use a AS or sigma, whatever, square variance. So we have the time series data. We subtract the mean, like departure or anomaly, then square the departure or anomaly. The previous one, this one, departure anomaly. We square the departure. Then we sum from T1 to N, then divided by N. That means we just mean the square. Okay. So the variance reflects the mean state of the difference between element values. That means that we have a time series data and sample average. Okay, these are variance. We can see the disperse of our data, like disperse data from the mean value. So we got the variance 0.05. So the difference between the mean value. Okay. Then we can, what is the standard deviation? Sometimes if we have large value, say for example, if you want to see the variance of distance like in meter or kilometers, okay, in meters, say for example, your variance is 200 meters from the mean value, then it looks odd, okay. Then we decrease the value. So then we just use the square root of the variance. This is called the standard deviation. Then it's understandable, like you can see the standard deviation is 10 instead of 10 or 20, instead of 200 or 300 is large value, okay? So it looks odd. That's why we use standard deviation. So we just square root the standard deviation, but we have the built-in function standard deviation. Probably in the last class in function, right? Function in MATLAB, I showed how to make function for variance standard deviation, isn't it? So we know how to do that, but we have the built-in function STD. STD means standard deviation. VR means variance, okay? So for the standard deviation, we just use the square root of variance. So this is a standard deviation, okay? Then we can also see the minimum, maximum, and range. Minimum is the smallest observed value, then maximum is largest observed value. And what is the range? Range is the between the maximum and minimum value. We can see the data. What is the range of the data? So we can know the dispersion of the data. If you have two data set, if one data has the large range, another was small, so you can say that data A is is more dispersed than B. So you can compare the dispersion of the data. You can see the range. Okay. Anyway, we can run standard deviation, minimum, maximum, range. So minimum is function is mean, maximum function is max, range is range. You can run it. Yeah. So you know now we have maximum value. Then we have minimum value, we have a range, okay? We have a standard deviation, we have a variance. If you use any software, you will get the result within second, but you need to understand why are you using this statistics and what the application, what the interpretation, okay? Anyway, now we can also calculate the correlation. We want to know the correlation between two samples or two variables, okay? So what is the correlation? Okay. Let's run the correlation, then we can calculate in MATLAB. Okay. I hope you guys are hearing, right? Are you sleeping? Shamma? Hello? Are you hearing me?
Hello, attendees.
Probably they are sleeping.
No, they are listening. Maybe they are shy to speak, I think.
I'm joking.
Yeah, yeah,
But it seems in online class.
exactly. Exactly, yes, yes.
Uh,
Hello, guys.
anyway, I will upload this video on my YouTube channel. You can also watch later, but it's important to understand. Nobody
Exactly.
give you time like this, even it's in free. It's free. So maybe in future I will be so busy. I don't have time to. So this is a good chance to learn now. Huh?
True.
Okay. The linear correlation is like we measure the linear relationship between two variables. If you want to know the relationship, so the relation can have positive, even the negative correlation. Okay, so if we get the correlation coefficient, we for the sample we use R. For the population is this is rho. Okay, if you have the positive value of R, that means the positive correlation. If you get the negative value of R, you will get the negative correlation. Okay, so the magnitude of the absolute value of R indicates the degree of correlation. Say for example, if this is your R value, so the correlation coefficient R value ranges from +1 to -1, or -1 to +1, whatever you say. If you get the 0, that means no correlation. But if you get the positive value, you have the positive correlation. If you get the negative value, you will get the negative correlation. But it depends on the degree. But if you can say, if you get nearly 1, then you say the strong positive correlation. If you get the value near to -1, you said the strong negative correlation. It happens in reality, in nature, right? Some factors have negative correlation, like temperature, rainfall, or etc., like potential evapotranspiration and drought, or like climatic water balance. You have the negative correlation, isn't it? If one is increased, another is decreased, isn't it? Okay, let's calculate the correlation coefficient. R is a correlation coefficient, but this is a hypothetical testing. Okay, this is a hypothesis. I need to know more about the hypothesis. This is a p probability p value. We reject the null hypothesis if we get the p value less than 0.05 or less than 0.01. This is like 5% significance level, or 1%, or whatever we can say, 95% confidence level, or the 99% confidence levels. Okay, you need to run this thing. This is like the hypothetical hypothesis testing. Okay, so now we have a temperature data. From data, temperature and rainfall, we want to make the correlation between temperature and rainfall. In the last class, I showed you we can get the output from a function. We can get output 1, or we can also get output 2, 3, 4, 5. Can you remember? Then in that case, we can use the square bracket. Can you remember the last class? So from this correlation coefficient function, we want to get two output. One is R, correlation coefficient, another is P value, probability P. Okay. Then you have the X and Y. What is the X and Y? One is independent variable, another is dependent variable. Did you get it? Hello. Let's run and see the R and P value. So R is 0.71 and P is less than this is 0.00019. That means what we can say from these results, we can say there is a significant positive correlation, okay, because the p-value less than 0.05, even 0.01. That means 95% confidence level, even the 99% confidence level, we got the significant results, okay. So then we can say there is significant positive correlation in between temperature and rainfall, right? If the temperature will increase, rainfall will increase, like more temperature, more evapotranspir, more cloud, more rain. Isn't it, Shamma? Huh? Hello? Samuel?
Yes.
People are sleeping.
Wait, I can call name.
Yeah.
Kazora, Jonah.
Because if you don't say something, if you don't respond, like class is like, yeah, it's
Maybe
like class.
you can ask some questions to
Yeah, like you should respond.
Afzal.
You should respond. Yeah, I'm hearing you, or okay, I understand. Or if you have the confusion, if you can have some questions, right? This is a statistical class, so understanding is the key. Like within, you can calculate the correlation coefficient. If I didn't say this background, if I don't say the explanation, you can't explain your results, isn't it? It's like the number of publications, just publishing a lot of papers, but you don't have the knowledge. It's not good. So you should have publication, you should have the knowledge. Like in any software, even in Microsoft Excel, you can calculate within second. But you understand the explanation, isn't it? When you read scientific paper, get like they will say 95% confidence level, 99% confidence level, or 5%. What does it mean, right? You need to understand the relation. Anyway, now we want to know the regression. Okay, so let's try to learn the regression. What the regression means. Okay. Anyway, regression, something like you want to predict the data, right? Prediction, like this is a linear regression equation. So y is the output, or you can say the dependent variable or predictant, whatever. Then we have a mx plus b. So m is a slope, okay? Slope, or we can say the trend. You always analyze the trend, like Mann-Kendall trend, etc., right? You said the increasing upward trend, downward trend. What is the upward, downward? This is a slope. So if you have the positive below, this is the upward trend. That means something is increasing, isn't it? If you get the negative value, then something is decreasing, isn't it? Then what is the x? X are independent variable or predictor. But if you use a function like f of x, y is equal to f of x, like x is an input and y is the output, isn't it? Like a function. You give input, you get the output, and b is a constant. Anyway, what is the R square? When you calculate the regression, we got the R square. R square is the percentage of variation. It's like ratio. The equation is like sum square, ratio of sum square regression to the total sum squares. Okay, we can say the percentage of variation, like in the values of the predictant, dependent variable that can be explained by the variation of the independent variable. So for example, how y changes as a function of x, like y is equal to f of x. Did you get it? How much y changes as a function of x. This is the regression. So R square is between 0 to 1. Okay, the percentage of variation. So for example, if you get the value of R square is equal like 0.7654, what does it mean? You need to explain, isn't it? It means the percentage of variation. That means if we make the percentage, if we multiply it with 100, then you will get the 76.54%, isn't it? That means 76.5% of variance Y can be explained by the changes in X. That means our Y changed 76%, 76.54, like around 77% changed Y changed by X, isn't it? As a function of Y change as a function of X by 76%. What about the remaining 23.46% of the variation? Is presumed due to the random variability, like it's a random variability, or if you have the other factors that happen in the data, like remaining random variability 23%. Okay. So finally, when you run the regression function, whatever in Excel, MATLAB, whatever any, you will get like the equation like this. Okay, what does it mean? Like y is equal, this is what? M is what? Slope. X is our independent variable, right? This is a constant. Then you will get the R square like 0.54, this value. So this is a regression between air crude and yield. That means relation between mesh, air diameter and yield. So air diameter, mesh air diameter is in centimeters. Then yield is in kg. Okay. So linear regression model is y is equal this equation, right? So what does it mean, the slope? This is a positive value. That means increasing trend, isn't it? So we can explain it like, if air diameter increase by is 1 centimeter, then yield will increase 11.94 kg. Did you get it? If for the if 1 degree centigrade temperature increase, how much rainfall will be changed? Or in like 11.94 millimeters like this. So we can say like this will increase in future regression to some prediction, like this. And what is the variation? R square 0. Like 50% change. The yield of the mesh will change 50% by mesh air diameter. Ma? No yante, no yante, no yante. Okay. So regression analysis, M is the slope. Okay. Then R is equal correlation coefficient, and B is a constant value. Okay. Let's run. We can use a regression function, built-in function. Then we have a independent variable temperature, the rainfall. Then we just want to get the one value. We don't want to get the for every sample. Okay. Just want to get the one value. Okay. What is that? 0.71. Okay, the strong positive correlation between temperature and rainfall. What is the M? Slope was 11.94. Is you get it? So if 1 degree centigrade temperature increase, the rainfall will increase by 11.94 millimeters. Okay, ma? Okay. Then how to get the R square? Okay. So we need to fit a linear regression model. Then you can get the R square value. So in MATLAB, there is a built-in function fit LM. LM means linear model. Then you have a X and Y, like temperature and rainfall. You can build a linear regression model, MDL. Then from MDL, you can, when you use a built-in this, can you see my screen? So we built a linear regression model. So it's a linear regression model like Y is like this. So estimated coefficient, intercept, ACT, T value, etc., T statistics, P value, etc. The number of the 16. Then what is the R square? The root mean square error 2.5, R square is 0.50, adjusted R square is 0.47. AV statistics like this. So when you fit the model, you will get the R square, even adjusted R square. But if you want to access from there, also you can access like MDL.R square, ordinary, another is adjusted. Just run, and you will get it. So 0.54, 0.47. This is for the tonight. Tomorrow we will finish the class. We will show the visualization. Thank you so much. Do you have any question? Yo, Wentima.
Finished.
Yes.
Okay, so
Hello.
hello. Do you have any questions? Attendees, please. No question?
Yeah.
Neo anything? Hello?
If you don't have question, we can finish.
We can finish the class.
Okay, thank you so much. I will upload on YouTube. Even I will share all materials on my generator repository tonight, inshallah. Yeah.
YouTube channel. Thank you. Thank you, Mr. Jalal.
Mhm.
Today's so tomorrow it is the final session
Yeah.
of this class.
We'll show the visualization.
In
Thank you
MATLAB
so much.
plotting. Welcome. Okay, bye-bye.
Bye.